Peter Newman's a dairy farmer with a herd of more than 300 cows. His cows are healthy, well-watered and good producers. Like many other farmers, Peter's an innovator. He's proud of the way he's engineered his farm water supply, and we'll see why in a few moments. Trevor Hockenhol's another innovator. He's a nurseryman with a successful and growing business. With more than 50,000 plants already in production, he needs a good water supply, about 30,000 litres a day. Both of these men have joined a growing number of New Zealand farmers in using their own energy for pumping water and paying absolutely nothing for it. And it's this development that makes it possible: the Williamson automatic ram pump. The big advantage of a Williamson pump is that it uses natural energy that would otherwise go to waste. For anyone installing a Williamson pump, this is the first requirement: an adequate supply of water. The flow available needs to be at least 20 times greater than the volume you want to pump. However, if you've only a limited supply of clean water, it may be possible to pump it using a nearby supply of dirty water to supply the energy. There's a second requirement. The water used for pumping has to be discharged somewhere below the level you take it from. It's this fallen level that supplies the energy used for pumping. Even with only 1 meter of fall, you can pump water to a height of 40 meters. You can think of your Williamson pump as an energy transformer, tapping some of the stream's energy to provide you with high-pressure water. You can pipe it anywhere you like. The question most people ask when they first see a Williamson pump is, how does it work? The design is sophisticated, but the principles are quite simple. There are two critical parts to the installation: the drive pipe, which supplies the hydraulic energy, and the Williamson pump, which acts like a hydraulic switch. It transforms the hydraulic energy from a high volume of water at low pressure and uses that energy to pump a smaller volume of water at much higher pressure. Imagine the drive pipe initially full of water. This particular pipe, for example, contains about 66 kilograms of water. The water comes from a surge tank at the top and flows down the steel drive pipe, which has been laid at the optimum gradient of 1 in 4. When the pump's drive valve opens, water can escape from the bottom of the drive pipe. As it gushes out, velocity in the drive pipe builds up very quickly. When it reaches a critical level, it triggers the drive valve, which immediately snaps shut. And suddenly, all the water flowing in the drive pipe is brought to an abrupt halt, creating a momentary surge of high pressure in the pump. The pressure wave forces open the store valve, and some of the water flows into the pressure tank to relieve the built-up pressure wave. Then the store valve closes again. As it does so, a small reflected pressure wave travels back up the pipe, causing a momentary negative pressure zone in the pump. At this moment, there's nothing to hold the drive valve closed, and it opens again under its own weight. Water immediately begins to escape. Velocity builds up in the drive pipe, and the cycle starts all over again. Every time the drive valve snaps shut, the drive pipe acts like a battering ram, forcing some water into the high-pressure tank. The drive valve is the only adjustable item on the pump. You can alter its stroke very simply by releasing the lock nuts. Lengthening the stroke will make the pump cycle more slowly. This increases both the amount of water pumped and the amount of water used to drive the pump. Shortening the stroke has the opposite effect. Notice that the pressure tank is only partially filled with water. There's a cushion of air above the water level at all times to act as a shock absorber and a reservoir of pressure energy. To maintain that air cushion, there's a breather vent, a small orifice just beneath the store valve. A small gulp of air enters the vent at each negative pressure cycle just after the store valve closes. The entrapped air stays there until the next pressure cycle, when it passes into the tank with the rush of water. The vent can't become blocked. It's kept clear by the short burst of high-pressure water which escapes through it at each pressure cycle. A Williamson Ram pump isn't the only way of pumping water, but it does offer some unbeatable advantages. The most obvious one is running costs. There aren't any. The average Williamson pump will pay for itself in well under 18 months when compared to electrical pumping. That's equivalent to a return on investment of better than 60% per annum. The savings continue indefinitely, and they're inflation-proof as electricity costs keep rising. Advantage number 2 is reliability, something that's essential in a farm water supply. A properly installed Williamson Ram pump is virtually maintenance-free. This is one of the originals, installed more than 5 years ago. It's been totally reliable, just like hundreds of others installed over the same period. There are plenty of testimonies to Williamson pumps. This map, for example, shows where some of them are installed in the Waikato area alone. There are many others not shown. We ran out of space to put the markers. Spares are always available, but nobody buys any. You can understand why when you see how the pump's engineered and constructed. Reliability is designed in from the start. All critical metal parts are either stainless steel or they're plated for corrosion protection. Valve stems are stainless steel sliding in polyethylene bearings. Valve seats are urethane, a special long-life polymer with shock-resistant properties. It's so tough that many skateboard manufacturers use it for their wheels. These 2 valves are the only moving parts. No other pump could be as simple or reliable. Advantage number 3 is our special technical customer service to take the guesswork out of deciding what you need. For just a nominal fee, we'll send a consultant to your property. He'll bring the experience and equipment necessary to survey your water supply and give you the right recommendations for a suitable pumping system. He'll check the lie of the land, the amount of fall available, and suggest a suitable layout. Measuring the available flow is very important. He'll use one of several techniques to suit the stream on your property and recommend the right pump for your requirements. We've a wide range of pumps from 25mm to 300mm, with pumping capacities up to more than 500,000 litres a day. And even if you want to raise water to a mountaintop, the Williamson Ram pump will do it, generating up to 40 meters of pumping head for every meter of fall available at the pump. If you've only a limited amount of clean water but plenty of dirty water, you can use this version of the Williamson Ram pump. The clean water is piped in through a special port just below the store valve. To demonstrate how well it works, we've added some red dye to the main supply of dirty water. As you can see, there's no contamination of the pumped clean water. Advantage number 4, you can install a Williamson pump yourself. We supply complete installation instructions to provide all the information you need. You don't have to hire an electrician, a fitter, or a plumber. There's also a helpful video that explains what to do and shows how to do it. If you can prepare concrete foundations, make good pipe joints, and work accurately, you can install your own pump. And when the job's finished and you start it up for the first time, you'll have the satisfaction of knowing that you're using energy that would otherwise go to waste. The satisfaction of making an investment that will return you more than 60% per annum on your money. And the confidence that comes from knowing you've got a secure and reliable water supply, free from breakdowns, and completely independent of power cuts. Thanks to your Williamson Ram pump.